Thank you. So 50,000 generations ago, Homo sapiens appeared, and in just the last 1% of our time on Earth, we began making architecture to tame harsh environments and express physical, psychological, sociological, and aspirational needs. Now, just in the final 1% of our time, we have started pressing into places utterly alien to our origins and our being: the Arctic, air, undersea, and space. And while we are doing that, we are using architecture surely, and the field is defined as the practice of designing and building inhabited environments in outer space. As it's a newly emerging field, and constructions are high risk and high cost, and the time period from determination of a goal to realization of it is really long, and the design problem is really complex, subject of various disciplines. The field is a little different than what we are used to as architects. The design process is extended, and we need interdisciplinary approaches, as architects solely cannot be able to solve the design problem of the space habitation as a whole. The need for there is a sufficient approach to work all together. And there are some issues about going to space, such as breach capability, environmental issues, and making human thrive there. So the well-being of human cannot be separated from the architecture that he or she is in, especially in space, because it's the only environment that they can be on. If you consider the the suits that they are wearing on EVAs, it can be still considered as an architecture. So the architectural environment is the whole environment that they can get involved with, and the conditions there is different from Earth, and it causes some issues on humans. I'm gonna try to be quick to make up for the previous presentation of ours. And so there, gravity conditions is one of the most extreme ones, if changed. And the light, if changed, in Leo it's different, in Moon it's different, and in Mars it's different. But if we don't have an atmosphere, it's much different perception of light, as it's not dissolved and make any color change or something. And some other factors, such as the user type and activity during stay and the duration of stay, it also affects how the architecture should be. And also the architecture should be able to be tried here first, as we don't have a trial error approach in space. We need to be able to try it there. And when we look to the technology aspect, we don't only consider today's technology, but we have a time span, a long time span to make those technologies, so we can present some technologies that are not here yet, but can be possible in a decade or something. And to be able to fund it, to be able to make those things realize, the issue of spin-in and spin-off becomes really important. It's of course beneficial for Earth and space to get help from each other, but if we can't create a concept that can provide some benefits for Earth, food solely for Earth, we may not have funding. We may not able to develop that technology. So to quickly sum up, on one side we have environmental concerns, and on other side we have human aspect of the issue. And our habitat should respond to those both sides. So where architects stand on the design of space habitats. This is from Nigel Cross. After he refers he refers to Lawson's experiments, which he made on engineering and architecture students, and concluded that scientists problem solve by analysis, whereas designers problem solve by synthesis. We have some different approaches coming from our education, and it's best if we can work together and combine all those point of views. And there are a lot of fields that the space architecture is involved with, and this is Hoplik's interpretation of how much involvement can there be from different fields. Architecture seems the field to be involved in all of them. That is because it's kind of having a broader subject of study, but not that doesn't mean that architects are the experts on all those issues. They can understand and try to get all concepts together. For now, Griffin, one of the space architects, states that now space architects are currently contributing to mission planning, vehicle integration, habitat design, human factors, design integration, and concept development. However, there is this thing that space architects try to. Mark Cohen is one of the all the space architects again, and he suggests space architects to talk about the function, the structure, the mass, the cost, the viability, and the safety, the crew productivity. And he makes this. He says that validate what you are doing. Because you need to work with engineers there, so intuitive decisions are not gotten. And this is again a quote from Griffin, which he states that space architects are different than architects. He says they analyze like an engineer and synthesize like an architect, hopefully. So if we look at the timeline of space habitation, we can see those human habitat space stations starting from Salyut, and I have two quick stories, one of which is from Salyut, in which the engineers only have designed red boxes for human habitation places. So the design mission director called an architect to be involved in the designs, which is Galina Balashova, the first space architect. She continued her works for decades after that. And this is from America in the same decade, late in the same decade. Here again, even the astronauts that are going to live there thought it was okay to live in an empty propellant tank, and not much. They thought they didn't need much special allocation or integration of stuff. But the later things have proved that it was important to have an architect and designer involved in the designs, which was Lowy's firm for Skylab. And again, he contributed in a lot of ways to the designs there. Skylab project is an extreme collaboration between many parties, and they claim that the teams were so tightly integrated that they sometimes lose control which one is which. In Salyut, engineers, again, the thing I have just mentioned, engineers made a habitable module, but made it without thinking about comfort and coziness. And Korolev didn't like it, and one of Korolev's assistants who knew me recommended me for the interior project, says Galina Balashova. And George Muller, the program director of Skylab, after Lowy's interventions, he says, okay, nobody could have lived in the previous thing, the empty propellant tank, without those interventions. And in Salu, you can see some of Balashovan's works, which actually have been strictly examined and executed. And in Skylab, again, Lowy had a lot of sketches, design research and implementations to the design. In Mir Space Station, we again see Galina Balashova's work. And in ISS, this is from Mark Cohen. He has works on the integrate, how the orientation and the coming together of the modules are gonna work. This is not implemented in such a strict way. It has been altered, but have been used. So the thing about mockups, analogs, and experiments is it is important to be able to test the design here first. And while doing that, it is good to have considerations about architecture too. And for example, in Skylab, they were thinking about doing the construction of the interior and pressurization up in there. But after they have get in the natural buoyancy lab and tried the things in the underwater, they have seen that it wouldn't be possible to do it that way. So they changed the whole design concept to be all done on Earth and then to be shipped. So there are, of course, some other factors that are involved in design, and mostly Sherwood says that mostly the design aspects, the human well-being things that we try to get in are being eliminated when there is a cost-related issue. But you see in every astronauts or cosmonauts, in everyone's diaries, logs, you can see how they always mention the space and mention windows, weightlessness, private and common volumes, colors, mentioning a lot about the space. So and until now, there have been many examples that an intuition of the architect, such as providing windows, would be beneficial. After have been proved supported by research and also by experience. So even for now, we need to validate and validate our designs. We need to rationalize our designs while designing for space. I believe that it is a little controversial if architecture can be rationalized. Thank you. Bye.